What if you could teach a machine to predict the future? Seriously, it's not science fiction and it's not magic. It's all about giving that machine a memory. In this explainer, we're going to break down exactly how you can teach a computer to understand yesterday so it can make a scarily accurate guess about tomorrow. So it all boils down to this one big question, right? We have mountains of data, records of everything that's happened before. But how do we get a machine, just a piece of code, to look at all that history and actually tell us what's coming next?
And the answer? Well, it's actually really simple, but it is incredibly powerful. Before a machine can even think about predicting tomorrow, you have to teach it to understand yesterday. That one idea right there is the key to everything we're about to do.
Now here's the real problem we're up against. You and I, we get time. We know that today follows yesterday and tomorrow comes after today. But a standard machine learning model? It's completely time blind. It doesn't see a flowing river of events. It just sees a bunch of separate, disconnected snapshots. It has no idea about the sequence.
So that's our mission. How do we solve this time problem? How do we take all those isolated snapshots and teach the machine to see the timeline, to see the connections that are so obvious to us? To make this super concrete, we're going to get our hands dirty with a real-world challenge, predicting the minimum daily temperature down in Melbourne. We're not just going to talk about theory, we're actually going to build a forecasting engine step by step.
And we're using real data to do it. A whole decade of daily minimum temperatures from Melbourne. But right now, it's just a long, kind of boring list of dates and numbers. Our job is to turn this simple list into something a machine can actually learn from.
And this is where our hero comes in. The solution to this whole problem is a super powerful technique called feature engineering. This is exactly how we're going to give our timeline model the gift of memory.
So what on earth is feature engineering? You can think of it like being a data detective. It's the art of creating new, helpful columns, we call them features, from the data you already have. It's how we add all the juicy context and meaning that the model just can't see on its own.
Our first tool in the toolbox is something called a lag feature. And honestly, it's as simple as it sounds. We literally create a new column that tells the model, hey, by the way, this was the temperature yesterday. It's the most direct way to give our model a little bit of short-term memory. And here's exactly how that looks. Check out the row for January 2nd. The temperature was 17.9 degrees. Now look at our new column, yesterday's temp. We've just put in the value from the day before, 20.7. See, now on one single line, the model can see both today's temp and yesterday's temp. Simple, but a total game changer.
Okay, so knowing yesterday's temperature is great, but it can be a little jumpy, right? To see the bigger picture, the overall trend, we need another tool, the rolling feature. This helps the model squint a little and see things like the average temperature over the last week, which helps it ignore the random daily noise.
And the process is super straightforward. First, you just pick a window size, let's say 7 days. Then, you slide that window across your data 1 day at a time. And for every single day, you just calculate the average of all the temperatures inside that little window. That's it.
All right, so now we have our secret weapons. We've got lag features to give the model memory and rolling averages to give it a sense of the trend. It's time to put it all together and build the final data set that's going to power our forecasting engine. And just look at this. This is the transformation. On the far left, that's our target, the temperature we're trying to predict. And everything to the right? Those are our brand new features, the clues the model will use. Yesterday's temp, the temp from the day before that, and the average over the last week.
And just like that, with a little bit of clever engineering, we've done it. We've turned a tricky time series problem into a standard supervised learning problem. We now have a clear target and a set of clues to learn from. Our data is finally ready.
Okay, now for the really exciting part, the moment of truth. We've built this awesome, rich data set, but does it actually work? Can a model take these new features we made and actually make a better prediction? Well, let's find out.
Before we test our fancy model, we need an opponent. We need a benchmark to beat. And for that, we use what's called the naive baseline. It is the simplest, dumbest guess you can make. Tomorrow's temperature will be exactly the same as today's. Any model we build has to be smarter than that.
So, how good is that simple guess? Well, on average, it's wrong by about 2.2 degrees Celsius. That's our score to beat. To prove all this feature engineering was worth it, our model has to have a lower average error than that.
So, here it is, the big question. We took our new data, we fed it to a powerful model called a random forest. Was all that work worth it? Oh yeah,
Absolutely. Our model's average error is just 1.8 degrees Celsius. That is a huge improvement over that simple baseline. By giving the model memory and a sense of the trend, we built a genuinely smarter forecasting tool. Success!
Beating a baseline is cool for a test, but the real power is actually using this thing, right? We can now take the most recent real data, feed it into our trained model, and get a real, concrete prediction for what tomorrow's temperature is likely to be. This is where it goes from theory to a practical tool.
And while predicting the weather in Melbourne is a great example, the power of this technique goes so much further. We haven't just learned how to predict the weather, we've learned a fundamental method for forecasting pretty much anything that changes over time.
I mean, just think about it for a second. This exact same logic, creating lags and rolling features, is used by giant retailers to predict how many shirts they're going to sell, by power companies to forecast a whole city's energy needs, and by tech companies to guess how much traffic their website will get. The applications are absolutely massive.
So, we'll just leave you with this final thought. We've shown that by being a little clever with our data, we can give a machine a sense of history. And once a machine can truly learn from the past, its ability to predict the future becomes incredibly powerful. The only question left is, what would you want to predict?